Okay, our next video is going to start walking us through Lab 0, which is really the first real assignment. So I know that some of you have coded a fair bit before, whether you use C++ or Python or JavaScript or some other software language like that. Some of you have maybe made web pages in HTML or CSS, or maybe even you just made some scripts in things like Visual Basic or even Minecraft. And if you've coded even just a little bit before, this first part is going to be pretty easy for you. But I'm really going to go slow because I know some of you have never coded before, and coding is going to be sort of a big lift as part of this class. So, here I've just logged into the virtual machine. I've opened up RStudio, and we're pretty ready to go. I switched to my project, which I called data management. You could have called yours whatever, and it's living on the Y drive. If you're working on your own machine, you should make a project that just lives on your own drive and that you can access however. To start with, I'll mention that R does come in versions that get updated every once in a while. The one at Truman is updated every summer. So since this is the beginning of summer, we actually have the one from last year. After the name of the version is actually this little phrase. This one is Joy in Playing. They all actually come from Snoopy cartoons. So if you're interested, you can Google the name of your version or my version and see what thing that is. And that makes it an easy way to see. Because we are sometimes doing modern things, using older versions sometimes does cause a problem. So on your own machine, I would recommend updating as often as you can. Like I said, the Truman one only updates once a year. Okay, so we're going to talk about Lab 0. So it's listed here under week 1. You can see I haven't made it public yet because I'm still showing it to you. And you click on this Google document. When you click on it, what it's going to do is it's going to make a copy of this Google document for you. So you click on it, it's going to open a new tab. And when you do that, this tab is now yours. Other ones, when we don't do that, you have to make a copy so that you have one that you can scribble on. For some assignments like this one, I'm going to give you the script inside a Google document. For others, I'm going to share the document with you more directly. Now, here's one complicated part. It's actually pretty annoying to copy and paste from outside the virtual machine to inside the virtual machine. So I'm going to actually go inside the virtual machine. This is a fake desktop, not my actual one, but the one that lives inside the virtual machine. And I'm going to open Chrome within that. And again, that's sort of one more annoying step for you. If you're on a campus computer, it actually takes you here automatically. And I'm going to go to classroom.google.com. And from here, you'd have to log in. So I got it, and I'm going to sign in to Google Classroom. And when you do that, you just log in as yourself. Now, you have to make sure to log in with your Truman ID, not your other Google account. And you'll know that it's the right one because it has the Truman logo for that. You can save it or not because it's going to often delete it because the virtual machine gets cleaned out very often. All right, so then here I am, and you can see this is the same as what I have out here, but this is on my machine, and this is inside the virtual machine. And so we click on it, and here's all the ones from before. Here is this new lab, which again, you can't see yet because I haven't put it up there. When you click on it, it's going to, you click on the link, it's going to make a copy just for you. Notice I have the tabs down here separate from the tabs up here, and that's a little bit confusing. All right, anyway, once we get that going, we can then go ahead and start to use it. Notice everything I'm doing here is inside the virtual machine. Now, the first step in using the software is to remember that the console window is live, so it doesn't remember anything. So we're going to actually make a different window called the RScript window. And it's up here. And what it does is it's just a notepad that you can store things on. It actually, when it saves things, it actually saves them as a notepad text file. So then we can just copy and paste what we had before. And that will be the assignment that we have. I just clicked on the wrong one. Shoot, well, let's go back and get the right one then. It is RLab. I need lab 0, not homework 0. Well, good. Now you can all see that I mess up just as much. Okay, there we go. There is RLab 0. Good, because that was all text and that will look funny. All right, so now here I am copying my RLab into the script window here. And now we're ready to go. I'm going to scroll back to the top. Anything that starts with a hashtag or a pound sign is going to be a comment, so it's not run. And anything that it's actually going to run is going to be different. You can see on the default at the Truman setting, the text here is green and the text for actual code is blue. As soon as you open that, probably the first thing you want to do is save your text. Again, you can just call it something like lab 0, and you can save it as lab0.r. The computer will often give it the right prefix for you, the suffix for you, .r, but if we call it .r, that should work. And you can see over here in the file window that lab0.r is now ready to go. Okay, so now we've copied everything over to there, and we can start to go. The first part of this lab is actually text, and you can read that, although they're mainly things that I've talked about. Now, the things at the top don't run automatically. That's done down in the console window below. So this is your notepad, and this is your computer. So if you go all the way down here to line 84, you can start running things. And to run things, you don't hit just regular enter. If you do that, it just puts a blank line after it. Instead, you either hit the run over here, or if you do control enter, that will actually execute the line. You can highlight a whole bunch and run them all together if you wanted to do that, and then it'll give you all 3 commands. And you should have gotten 5, 6, and 8 for those. So again, the idea of the document up here is that this gets saved, and you can use it later. Down here are what the actual calculations are. Okay, so we're going to want some data because, right, this is a data science class. We're going to do data. So the command that we're just going to start with is called data. Remember, all commands in R just put data and then parentheses. All commands use parentheses to store things. So when we do that, it's going to open a new window up here. And here are all the built-in default data sets. And of course, some are cool and some are clever and some are fancy. But from within there, you can find some data sets you're going to use. We're actually going to use this data set called US Judges Ratings. And that's going to let us just check out our command. So we go back to our script window, and we can get our help menu with the question mark. So if we do US Judge Ratings and we hit Control Enter, over here it opens a window just giving you some information about that. Now, this is sort of a weird data set. It's actually a data set from the 1970s where 43 lawyers were given, 43 judges were rated based on 12 variables. And if you just type its name, you can see the actual data. Notice that just really gives you a data dump and it just kind of spits it out at you. This was 43 rows with 12 columns. These are the names of the judges, and these are the averages across multiple responses. So each respondent gave a survey or whatever, and it was evaluated against it. Okay, so that, of course, worked okay for 43 rows, but if you had a whole bunch more, you might not want to see all those. So we can use the head command. Head just shows us the first 5 lines or 6 lines, and that's a lot easier to look at, and you can get a good sense of what the data looks like. Of course, the health menu tells you what each of the variables are. You might assume that these are 1 to 10 scale questions, because that's how we think things might look. And so you can go ahead and check it out from there. The view command is another version to do that, and it actually makes the whole data set open here as a separate tab. This is nice for us to look at, but it's actually not very good because When we make output, this isn't included. So view is good for us to check out the data, but if we're actually knitting output, which we'll talk about in lab 1, view isn't actually as good of a way to do it for things you're going to put on a web page or into a Word document or do something like that. All right. There you go. So next I want to talk about the $sign. So $sign just means let's look at a single variable at a time. So if we hit US Judge Ratings $sign R10, R10 is the retention score. So the lawyers were asked, is this judge worthy of being retained? And if you do that, it just spits them all out in a row. So we don't usually use that much to look at the data, but that is how we're going to treat that for things. You could imagine doing a graph or something. The $sign is really handy. Now, a little bit later, we're going to be using a system called Tidyverse, which is a bunch of packages that help us do data management and cleaning in a more quick way. But you can also do things using the built-in system, which uses square brackets. So you remember I said parentheses are used for functions. Square brackets are used for subsetting your data. So for instance, if I did this command at line 150, US Judge Rating $sign R10, bracket, US Judge Ratings $sign R10 is greater than 8. That's going to just give me the values that are greater than 8. So you can imagine we only want to look at the top judges or the ones that have good scores. All right. All right, tab completion. So another thing that's sort of important is this idea that typing can get pretty tedious, especially if you think of really long commands like US Judge Rating .R10. So what you can actually see is if you type in US Judge, it'll give that to you. Then you can hit the $sign and it'll come up with all the variables, and R10 is the last one. So we can do that, and then we can hit the bracket and then US Judge, and then $sign R again, and then we can do R greater than 8. So even though it looks like that's going to be a lot of typing, because it auto-completes for you, it actually is pretty snazzy to do. So that's called tab completion. If you hit tab, it just fills in the rest of that value for you. So there you go. Now let's get down to some real statistics. So of course, the average is a value that you might want to see. So we can look at the average of R10. So that's what's the mean score of that variable. So the mean is 7.6. We can calculate the standard deviation with SD. Or we can use a command called summary, which looks at the ratings across judges. So summary gives you what's called the 6-number summary. And the 6-number summary is sort of weird, because those of you who remember from Stat 190 or your intro stat course, you would say, I thought there was a 5-number summary, not a 6-number summary. And what the 6-number summary does is it gives you the 5-number summary, the min, which is the minimum point, the first quartile, the 25th percentile, the median, which is the 50th percentile, the third quartile, which is the 75th percentile, and the max, which is the highest value. And then it stuffs the median right here in the middle. That's actually nice, because if the mean and the median are very close to each other, that's a sign you've got a symmetric data set, which is often handy to know. You might, again, remember from your intro stat course. And this gives you the range. You can see how far it goes from the smallest to the highest. Even though we think this is a 1 to 10 scale, the fact that no judge was lower than a 4.8 tells you that it's pretty right skewed. The max was a 9.2, which tells you that nobody was universally liked. Now, you might immediately want to say, well, gosh, if I had a graph, I could see this even better. So here's a quick graph from base R called histogram, H-I-S-T. And when we run that, you can see over here in the plot window that the histogram pops up. Again, we can see that the values go from 4 to 9. They don't actually go all the way from 0 to 10. And we can see that most people do clump in the middle. Again, this is just the simple histogram function built in, but it is actually pretty easy to add options. You can see options in R, you just put a comma and then the next option. Sometimes if you put them in order, you don't have to label them, but that requires you to remember things. So if you just look at the labels, you can add that, and now you can see that it made the X label and the histogram title a little bit snazzier. Again, if you hit $HIST, it'll give you tons of information about how to make histograms prettier. Now, there are many types of graphs you can make. Plot is actually a good command. So we might say, let's compare their physical score with their integrity score. And if we put that in, you can see here we go very quickly, we got dots. Now, base R is cool in that it tries to guess what kind of plot you want, and that's very nice. On the other hand, we're going to use a part of tidyverse called GGPlot, which will let us make much fancier, much prettier plots with only a little bit more work. So that's actually nice as well. All right, in the next video, we're going to start talking about packages and other extensions that we can make to get even more functionality within R.